Azure Active Directory Identity Protection is a security service that provides a consolidated view into risk events and potential vulnerabilities affecting your organization's identities. Today, we will be covering both admin and end-user experiences. To start things off, let's begin with the admin experience. Here, the dashboard gives you access to reports, such as users flagged for risk, risk events, and vulnerabilities, and also settings such as the configuration of your security policies, notifications, and multi-factor authentication registration. To show you the power of Azure AD Identity Protection and its user-friendly interface, let's investigate a discovered risk event. Risk events are events that were flagged as suspicious by identity protection and indicate that an identity may have been compromised. For today, let's further investigate the Impossible Travels risk event. Within the Impossible Travel blade, all flagged incidents are displayed by first and second login locations and the time each login occurred. Identity protection does not just provide you the visibility over suspicious activity such as impossible travel, but also allows you to take immediate action if necessary. Here, you have the option to choose from resetting the password, enabling MFA, or dismissing all events. Aside from addressing incidents on an individual basis, Azure AD Identity Protection gives you the capability to address possible issues through a proactive approach by configuring a user risk remediation policy. But before moving on to creating user risk policies, let's first take a look at users flagged for risk in order to gain a better understanding of the criteria user risk policies base their actions on. Within the Users Flagged for Risk blade, users who demonstrate suspicious activity are assigned the appropriate risk levels. The total number of risk events are tracked and also displays the current status of that user. A user risk level is an indication, high, medium, or low, of the likelihood that the user's identity has been compromised. User risk policies base their actions off a user's risk level. A user risk remediation policy is a conditional access policy that evaluates the risk level to a specific user and applies remediation or mitigation actions based on predefined conditions and rules. However, this policy is currently not enforced. Before enabling this policy, let's be sure to set it up properly. The recommended default for most organizations is to configure a rule for a medium threshold to strike a balance between usability and security. As you can see, the current policy meets the recommended guidelines, but let's also see what other options are available to choose from. It seems that there are quite a few more options to choose from. Depending on your current situation, you have the option of lowering or raising the conditions to trigger this policy. Now moving on to the type of action to be taken if and when this policy is triggered. Lastly, you have the option of either blocking access entirely or allowing access with the requirements of multi-factor authentication, Azure MFA registration, or a password change. By default, the setting of this policy is set up to block access entirely, which is the appropriate action desired for the identified risk level. Now, to save and deploy this policy to my environment. Now that the policy has been saved and deployed, all users who possess a user risk level of medium or above will be blocked from gaining access to any corporate assets using his or her corporate credentials. Moving on to the end user's experience. To test the user risk remediation policy currently in place, an in-private Edge browser and a Tor browser will be used. As presented, both browsers are using the same set of credentials. To start things off, let's see the specific hops the request will take when using the Tor browser. As seen here, it seems that the request will take 3 random hops to the Netherlands, then to Canada, and finally Romania before it hits the internet. If you aren't already familiar with Tor, Tor is free software for enabling anonymous communications and is a browser often used by hackers on the dark web. Now let's see what happens to the request when sent through the Tor browser. As you can see, the request sent through the Tor browser was immediately blocked, not allowing any type of anonymous sign-ins to occur. Now, to see what happens from the Edge browser. As expected, since the request was sent through a legitimate source, the login attempt was successful, just moments after being blocked in Tor. In a world of increasing identity theft incidents, persistent bad actors, and frequent security breaches, Azure Active Directory identity protection is a must-have.